Hello everyone and welcome to Trig for today. Today we are going to be working on section 6.1, which is an overview of angles, arc length, and circular motion. So these are pretty basics on Trig. A lot of you will remember this from when you last took your last math course, but these are the foundations for what you're going to need this semester. So first, an angle is formed by rotating a ray around its endpoint. So notation-wise, we have a couple of terms that you should be familiar with. When you're dealing with an angle, that center point is called a vertex. So that is the center point of the angle or the pivot point. The initial side is where we consider the start of the angle. So here you can see the initial side is considered to be horizontal, but that initial side can really occur anywhere. The terminal side is where the angle ends. So it opens from the initial side to the terminal side, and we call this part here, this actual distance inside, the angle itself. So initial side, vertex, terminal side, and the angle. Here you can see that the angle is notated as alpha. Now, if you are also, the angle looking the same could be opening in the opposite direction. So beta here is an angle with the initial side in the same kind of geographic location, but the terminal side this time is also in the same location, but the angle is opening in the reverse. We'll talk more about those angles momentarily. You can also have an angle where it rotates more than one full degree turn. So if you are talking about a rotation of more than 360 degrees, the angle itself can look the same, and this is called a coterminal angle with the first one. And we'll go through some more of those as we go along. An angle is thought to be or said to be in standard position if its vertex is at the origin or the point 0, 0, and the initial side is along the positive x-axis, and then it opens up from there. Now, an angle can be in standard position if it's positive and is opening counterclockwise, or if it's negative and is opening clockwise. So they are both considered in standard position because you have that vertex at 0, 0 and the initial side along the x-axis. Angles can be also measured in degrees. So a measure of an angle in degrees is about the level of rotation that terminal side has from the initial. So if we are measuring in degrees, we always have this little degree mark. So it's an open circle above the actual number. Measure of 1 degree is 1/360th of a circle. So we have 360 degrees for a full circle. I've outlined some of what are called the quadrant angles here, and these are the 4 quarters of the circle. So the first one would be 0 degrees, and this is if the initial and the terminal position are on the same line, so on the positive x-axis. Our quadrants, in reminder from when you last took your last math course, quadrants go counterclockwise starting here, and we always notate them with Roman numerals. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if we have an angle that is started in the standard position and opens to the edge of the first quadrant, this is 90 degrees. Now, some of you have also seen a right angle in that location. So if you have a square in an angle, that means it's a right angle and 90 degrees. If you have a line that is straight across, so an angle that opens all the way straight across, this is half of the circle, or half of 360 degrees, 180 degrees if we're going 2 quadrants. If we have 3 quadrants, we have 270 degrees. And if you were to do the entire circle all the way around, then you would have 360 degrees. That is 1 full revolution of the circle. Now, if I want to draw some angles in standard position, then my rules on standard position is that it has a vertex at the origin. So we're at the point 0, 0. I'm going to change the color so we can see it better. So we have a vertex at the origin, and our initial side is along the x-axis. Now it says that this is a negative angle. Negative angles move in the clockwise direction, so this angle is going to open this way. Now I need 135 degrees, so if I were to go one full quadrant, that's 90. 2 quadrants is 180, so I'm beyond the first quadrant turn and into the second. So I'm going to pen that in right around here. Remember, we're moving in this direction. So here we have a negative 135 degrees approximately. Now the second one says positive 212. So if I am looking at my axis lines, still in standard position, so point at 0, 0 on the initial side on the x-axis, and we want 212 degrees. So remember, we have 90 at the first quadrant, 180 at the second, and we are beyond that about 22 degrees. And here we have approximately 212 degrees. Now degrees is one way that we can measure angles, but it's not the only way, and probably it's the one that we won't work with as much this semester. The other is what's called an angle in radian measures. So first I want to talk about an arc. Now an arc, when you're dealing with an arc, it is the portion of a circle on the circle line itself. So if I'm looking here, the arc in purple is this part here. So that's an arc. Now, it could be a portion of the circle, it could be the entire circle, or it could be the circle plus some. So an arc is like an angle where it can be any size. The thing that I want you to know is that when you're dealing with the circumference of a circle is its distance all the way around. The circumference of a circle is calculated as 2 pi r. So you may use that later on in the semester, but the circumference is 2 pi r. Should be a formula that's a little bit familiar to you. When we're trying to figure out how much of the portion of the circle is 1 radian is the angle measure when the arc length is equal to the radius of the circle. So if you see on these diagrams, the arc length here in this first diagram is equal to r. The radius of the circle, or the distance from the center of the circle to any of the edge points, is also equal to r. So that angle here is listed as 1 radian. Now you can have more than 1 radian, or you could have a fractional portion of a radian, and we'll talk about those soon. Similarly, in this circle, this is actually a circle with a radius of 3. You see that the arc length is also listed as 3 here. So this central angle measure here is also 1 radian. Now you notice that radian does not have the degree mark, so if you are dealing with an angle measure and you do not have that degree mark, we're assuming it's in radians. So 23 degrees is in degrees. If you're dealing with an angle and it just says 23, we're going to assume that that's 23 radians. Be careful on this, because that is a common mistake, is to just assume that we have a degree measure when we don't. There are many different groups of radians. So remember, 1 radian means that the radius is equal to the arc length. But if the arc length is equal to twice the radius, then this mark here would be 2 radians. And so on and so forth all the way around the circle. So if you're starting at the initial side, 1 radian would be here, 2 radians when the arc is twice the radius is here, 3, 4, 5, and 6 go to here. Now, a circle itself, 1 full revolution is 2 pi radians. So 1 revolution of the circle is equal to 2 pi radians. We also have quadrant angles in radians. So if you are in the initial and terminal position are together, you either have 0 radians or 2 pi. Our 90 degree in radians is pi over 2. Our 180 degree in radians is equal to pi, and our 270 degree in radians is equal to 3 pi over 2. So if I want to draw an angle in standard position, given radians instead of degrees, this will rely a little bit on your knowledge of fractions. So if I'm looking at this angle in our standard position, I know that I'm going to open counterclockwise, so we're going this way because it's a positive angle. 5 over 6, or 5/6, is less than 1. Now, if we're talking about 1 in pi, in terms of pi, we have 180 degrees. So 5 pi over 6 would not make it quite that far, and I'm going to pencil in the angle right around here, 5 pi over 6. Now, if I have negative 2 pi over 3, negative direction means that we are opening clockwise instead of counterclockwise. So here is our initial part. And then relating this negative 2 pi over 3, looking at the actual unit, that's a little bit more than a half. So 2/3, if I'm looking at just this fractional part, 2/3 is more than a half but less than 1. So if I'm drawing that in, I'm going to put it right about here. Oh, that's neat. I'm going to put it right about there. We can convert between radians and degrees with a little bit of arithmetic. So if you're trying to convert from one or the other and you want a more exact kind of measurement, 1 degree is equal to pi over 180 radians, and 1 radian is equal to 180 degrees over pi. So if I need to convert something back and forth, I just pick one of these ratios and multiply by it. So if I want to convert to degrees, then what I want is the fraction that has degrees on the top. I have radians already, so I want to convert it to degrees. So multiplying this by 180 degrees over pi, we do a little bit of simplification of arithmetic, so our pi's would cancel. And I also can cancel out this 3 into the 180. So 3 goes into 180 60 times. And we don't cancel the degrees out because that's what we want to be left with. So 7 times 6 gives me 42, so I have 420 degrees here. Converting the other way, if I want to convert degrees to radians, then I need the fraction that has degrees to cancel out. So if I am looking here, this fraction here should have a degree mark on the bottom, and I'm going to multiply that by pi over 180 degrees. The first thing I can do is cancel out my degrees. I can actually cancel that 0 too. And I'm left with 15 pi over 18. 3 goes into both, so 5 here, 6 here, and we get 5 pi over 6. Now we can also find the length of an arc if we are given an angle and if we're given an angle and a radius of a circle. So that arc length, remember, when the radius is equal to the arc length, we have a radian, but we can find the arc length as well. We can also find the area of a sector. Now this is considered a sector, so this piece here that we cut out would be a sector, and we can find that area. The formulas for both of those are listed, and you will need to know formulas in this course. The ones that you do not need to memorize, I'll notate throughout as we go along this semester. So if I want to find the arc length and the area of the sectors, there is one important note. If your angle is given in degrees, you have to put it into radians first to use these formulas. So you may have to transfer them to radians from degrees. So if I want to find arc length, the first part, here I'm given a radius of 4.5 centimeters and I'm given an angle of 2 pi over 5. So 2 pi over 5 is already in radians, so I do not have to do a conversion. I can just use the formula directly. So my arc length S is equal to R times theta. So R is 4.5 centimeters. Theta is 2 pi over 5. Arithmetic, 2 times 4.5 gives me 9 over 5 centimeters. Now that's an exact measurement, so if you are looking to estimate that, you can put that in your calculator for estimation. Some of these applied problems like this, some of the arithmetic will be easier in a calculator. If you're talking about the area, then area is equal to 1/2 times r squared theta. When you are dealing with area, you should end up with squared units. So here we have 1/2. Our radius is 4.5 centimeters, and we're squaring it, and then 2 pi over 5. We can simplify a little bit. I can cancel these 2's. 4.5 is squaring, so 20.25, and we still have pi. Over 5, and we're centimeters squared. 20.25 divided by 5 will go in 4.05 times, so 4.05 pi centimeters squared for our area. Here's a different circle, so if I'm dealing with a different circle here, notice that I have 140 degrees for my angle this time. So if we want to change that angle, 140 degrees into radians, we multiply by pi over 180. Simplifying that, let's see, so we will multiply 9 and we get 7 pi over 9. All right, arc length, S is equal to r theta, so S is equal to the radius, which is 3, times theta, 7 pi over 9. This is in inches. Canceling the 3 into the 9, I get 7 pi over 3 inches for my arc length. For my area, 1/2 pi r, or r squared pi, or r squared theta. So area is equal to 1/2 3 inches squared times 7 pi over 9. The 9 and 9 cancel, so I'm left with 7 pi over 2 inches squared. All right, so now you have some work to do in section 6.1 in your homework. If you have any questions or concerns or any of this is confusing in any way, please reach out to me for an appointment or drop in office hours, and I'm happy to help. Have a good day.